Hey, good morning, students. I hope everyone is doing good. And let me talk a little bit about logarithms. Okay, we are covering at this time, at this moment, those models for simple and compound interest. Okay, so the compound interest leads us to an exponential function, but when we want to know some information, we need to go back to the inverse of that function, which is the logarithm function. Okay. Um, Real quick, I will show you this. What is a logarithm? Logarithms are another way of thinking about exponents. For example, we know that 2 raised to the fourth power equals 16. This is expressed by the exponential equation 2 raised to the fourth equals 16. Now, suppose someone asks us 2 raised to which power equals 16? The answer will be 4. This is expressed by the logarithm equation. Log base 2 of 16 is 4. Read as log base 2 of 16 is 4. Okay, so we have right here, we are going to work with the exponential function, but then we need to get some information from the logarithms. Okay, please analyze with me a little bit just this. Okay, if you as you can check, you're pretty familiar with the 4, which is the exponent. Okay, and regarding to the problems of compound interest, this 4 will represent the number of years. Okay, the number of years. So how do you find the number of years if you have the initial amount and you have the ending amount after applying this interest uh, during certain number of years? Okay, this 4 is the number that we need to get through the logarithm equation. Okay, so how do we rewrite from this notation, which is exponential, to this notation, which is logarithm? Okay, let's locate all the points. Okay, the first thing that we have is log. Okay, I will show you how to do it in the calculator. Log, and then you have this 2. This 2 is the base. As you can see, this 2 is base here and also is base right here. Okay, the answer from 2 raised to the 4th is 16, so it's next to the 2. Okay, and the exponent, which is here raised, is you have 2 raised to the 4th power, then you have the 4 here. Okay, so basically, this is the definition of logarithm. Generalizing the examples above lead us to the formal definition of a logarithm. Log base b of a equals c, which is the same to b raised to the c power equals a. Both equations describe the same relationship between A, B, and C. B is the base, C is the exponent, and A is called argument. Okay, and you have examples about equivalent logarithms and exponential equations. Let's cover a couple of them. This is very easy. You have the form, the exponential form, 5 raised to the second power is 25. You know that because you need to multiply 5 times 5. Okay, and 5 times 5 is 25. Okay, how do you write the same thing in logarithm form? Okay, if you go to the logarithm of base 5 of 25 equals 2. That means that in order to get this 25, this base should be raised to the second power. Okay, and this is what I have. And now let me show you here how to write these forms. Okay, so which of the following is equivalent to 2 raised to the fifth power equals 32? Okay, once again, the base is always the same. So this 2 goes here, log base 2. The base remains the same, 2 and 2. The answer for this will be the argument and goes next to the base. And the exponent that is on top will be here in the other side of the equation. Okay, let's go to another. Which of the following is equivalent to 5 raised to the third power equals 125? Okay, once again, let's locate the base. You have log base 3 is